Welcome to this lesson where we're going to now look at categorical variables. Now we know that categorical variables, the second type of variables that we can see in biostatistics and in our research work. Let me get this to work a little bit better. There we go. Let me remind you that categorical variables are not continuous variables, in that these are variables that cannot be put on a spectrum. Now, what gets people really confused, you cannot put on a spectrum, that's what the X means. What gets people confused is that they sometimes see categorical variables described in numerical format, and that's misleading. It gives you the impression that the variables can be put on a spectrum and therefore are continuous, when in reality they're not. So let me give you an example of such data. You may have come across data where the researcher is asking you for your opinion and gives you 5 choices, something that you see like on a Likert scale. And on the scale you've got 5 choices, and those 5 choices are as follows, after I erase this: that you strongly agree, just agree, have no opinion, that you disagree, or that you strongly disagree. Now these are categorical variables because you can't really put them on a spectrum. You can't say that to say that strongly agree is any certain number of units away from agree or no opinion. You may see people try to take this type of data and convert it into numerical designations such as 1, 2, 3, 4, and 5. But that doesn't mean that strongly disagree is 4 units away from strongly agree. That's an arbitrary distance that has no meaning in the real world. So you may see data like this reported as mean 1.6, for example, and standard deviation, and I'm going to make this up right now, 0.4. So the problem here is that you use the mean and standard deviation. Those are statistical tests that are used for continuous variables, specifically those that have normalcy, homogeneity, and independence. But they're continuous. These are not continuous variables because I could have easily have redefined the numerical designations as the following: 5, 4, 3, 2, and 1. And that would have made my means different. Maybe now my mean is 4.4. And maybe now my standard deviation is 1.2. So you can't use parametric testing, mean, standard deviation, on non-continuous variables, on categorical variables. So be careful when you see posters at conferences or when you're viewing a presentation in the audience and you see something that makes you think it's a continuous variable, when in reality you feel that it's actually categorical. So the best way to look at categorical data is to use a whole different set of statistical tools. And the most common tool that we use for categorical variables, although by no means the only one, but probably the most common one, is known as the chi-square. Now you don't really need to know how to do a chi-square. All you need to know is that when you see a chi-square, you should be anticipating that the variables that are being presented to you, the data that was collected, is categorical in nature and does not fit on a spectrum logically. If you do see variables that appear to be categorical and yet the data is presented using statistical tools such as mean and average and t-tests and ANOVA, then you know that someone has mixed up the type of test with the type of variable that they have. And that's pretty much it. Categorical variables can be tested in more than just the chi-square. There are some other tests as well. Certainly not something that we as medical students or residents need to know, or even fellows at this time, but you do need to know how to identify your variables, whether they're variables that you're collecting in your own research or in someone else's research that you're evaluating, so you know if the appropriate statistical tests are being used. Thank you very much.